When we hear words like nitrates, amines, or nitrosamines, they may sound purely scientific and distant from everyday life. But in reality, this chemistry plays a major role in food safety, medicine, and even industrial products we use daily. This presentation explores the invisible chemical interactions between nitrates and amines, and how, under certain conditions, they can form nitrosamines. Understanding this chemistry helps us make safer choices and explains why scientists and regulators take these reactions so seriously. Imagine this. You're enjoying a hot dog at a barbecue or frying bacon at home. Everything feels normal until chemistry quietly steps in. Inside that food, under specific conditions, two very common chemical compounds can meet, react, and form something far more harmful than either one alone. This is a hidden chemical story involving nitrates, amines, and nitrosamines. Today, we uncover how this chemistry affects our food, our medicines, and various industrial products, and why awareness of these reactions matters. Let's meet the key players. Nitrates and nitrites are common compounds that occur both naturally and through human activity. They're widely used in fertilizers, found in vegetables like spinach and lettuce, present in cured meats such as hot dogs and bacon, and even detected in drinking water. Amines are organic compounds derived from ammonia. They are found in protein-rich foods like meat, fish, and cheese, as well as in medicines, amino acids, cosmetics, and rubber products. On their own, nitrates and amines are not villains. The problem begins only when conditions allow them to interact. Nitrates are relatively stable compounds, but they don't always stay that way. Inside our bodies, or during food processing and storage, nitrates can be reduced into nitrites. This transformation can occur due to bacteria, enzymes, or exposure to heat. Nitrites are far more reactive than nitrates. You can think of nitrates as calm observers, while nitrites are the ones ready to initiate chemical reactions. This conversion is the first critical step toward the formation of potentially harmful nitrosamines. Amines are almost always nearby. Chemically, they are classified as primary, secondary, or tertiary amines, depending on how many carbon groups are attached to the nitrogen atom. They naturally occur in protein-rich foods and are also found in many medicines and biological systems. Among these, secondary amines are especially important because they are the most reactive with nitrites. When we digest food or cook protein-rich items, these amines can be present or newly formed, setting the stage for further reactions. This slide represents the most critical moment in the process. Under acidic conditions, such as those found in the human stomach, or during high-temperature cooking, nitrites react with amines. Nitrites form a nitrosating agent, which attacks the nitrogen atom in the amine. This results in the formation of a nitrosamine compound. What makes this especially concerning is that the reaction happens silently. There is no taste, smell, or visible warning. High heat during cooking can further accelerate this reaction. Nitrosamines are not just ordinary chemical byproducts. Many of them are classified as potent carcinogens. They can directly damage DNA, causing mutations that increase the risk of cancer, particularly cancers of the stomach, liver, and esophagus. The greatest danger usually comes from long-term, repeated exposure rather than a single event. Because of these serious health risks, regulatory agencies worldwide strictly control nitrosamine levels in food, medicines, and consumer products. This chemistry isn't limited to laboratory experiments. It occurs in real life. Processed meats like bacon, sausages, and deli meats contain nitrites that can form nitrosamines when exposed to heat. Nitrosamines are also present in tobacco smoke, contributing significantly to smoking-related health risks. In recent years, nitrosamines have been detected in certain pharmaceuticals, leading to major drug recalls. Industrial products such as rubber materials and dyes can also be sources of nitrosamine contamination. In every case, the same chemistry applies. Several factors increase the likelihood of nitrosamine formation. High-temperature cooking methods like frying and grilling significantly raise the risk. Acidic environments, such as the human stomach, encourage the reaction between nitrites and amines. Long storage times and poor quality control during manufacturing also allow these compounds more time to interact. That's why regulations limit nitrite levels and require strict monitoring, especially in food and pharmaceuticals. The good news is that chemistry also provides solutions. Antioxidants such as vitamin C and vitamin E can block nitrosamine formation by interfering with the reaction process. Food manufacturers carefully control nitrite levels, and pharmaceutical companies redesign formulations to eliminate risk. By understanding the chemistry, scientists can prevent problems before they occur. Knowledge doesn't just reveal dangers, it empowers prevention. The story of nitrosamines is a powerful reminder that chemistry shapes safety. By understanding how everyday compounds interact, we can identify risks, design safer products, and protect public health. Awareness allows consumers to make informed choices, while science supports better regulations and safer technologies. So when you hear the word nitrosamines, remember, it's not just a chemical term. It's a lesson in how small chemical changes can have big biological consequences, and how science helps us make safer choices in the world around us.